right, this is section 2.5. We're talking about multiplying fractions. The rules for this are to multiply two fractions together by multiplying across the top, which are the numerators, and then across the bottom, which are the denominators. All of your final answers for multiplying or dividing or anything like that need to be in lowest terms. And we talked about lowest terms in the last section in 2.4 about finding a common factor that evenly goes into the top number and in the bottom number, the numerator and the denominator, to put that fraction into lowest terms. And so we're going to do that at the end of our multiplication. So the first example is going to be 2/3 times 1/3. Sorry, it's supposed to be a dot. We would multiply across the top, across the bottom, and we end up with 2 times 1 over 3 times 3. Well, 2 times 1 is 2, and 3 times 3 is 9. And I look at this final answer and I make sure that there are no common factors, meaning no number goes evenly into the top number, numerator, or the bottom number, the denominator. In this case, I know that the only thing that goes into 2 is 1 and 2, and 2 does not go evenly into 9. So I know that this is my final answer. I know what you're thinking. I just said 1 goes evenly into both of them. But if I divide something by 1 or multiply something by 1, it's not changing the value of what I have. So 2/9 is my final answer. Let's try another one. 5/8 times 3/4. Remember, we multiply across the top and across the bottom, and I end up with 5 times 3 on the numerator side and 8 times 4 as my denominators. Well, 3 times 5, or 5 times 3 is 15, and 8 times 4 is 32. And if I have 15 and 32, I'm trying to find what number goes evenly into both of them, and nothing does. You can keep looking and it just doesn't work. It doesn't happen. So 15 over 32, or 15/32 is my final answer. So I have 5 over 6, 5/6, and 9/10. I multiply across the top, and I get 5 times 9, multiply across the bottom, and get 6 times 10. Well, 5 times 9 is 45, and 6 times 10 is 60. And 45 and 60 are not in lowest terms. They both can be divided by, I dropped my pen. Both can be divided by 5. And so I end up with 9 as a numerator. And how many times does 5 go into 60? Well, you would have a calculator to use, but you could see that it goes in 1 time. You get 1, bring down my 0. 2 times 5 is 10, so it's got a remainder of 0. So it goes evenly in 12 times. So is 9/12 as simple as they come? No, because I know, or I can notice here, that both of these can also be divided by 3. So is it okay that I didn't realize that 15 went into both 45 and 60 the first time? Yes, of course, as long as I keep simplifying or keep putting them into lowest terms until I find that final answer that can't be simplified anymore by a common factor. So this becomes 3/4 as my final answer. You can also simplify in what we call the diagonals. And so here's this problem. Instead of simplifying at the very end, meaning I won't multiply 6 times 7 across the top and 11 times 8 across the bottom and get an answer in fraction form that needs to be simplified. What I'm going to do is I'm going to divide first in the diagonals. And I have 2 diagonals. The first diagonal is here, and the second one is here. So let's look at the blue one first. Is there a number that divides evenly into 7 and 11 in that blue diagonal? Well, 7 and 11 are both prime numbers, so that means that nothing will go into either of them to simplify those. So I'm going to move this blue diagonal thing kind of out of the way here, and there. Now we've got the red one only. So inside that red diagonal, I see 6 and 8. Is there a number that goes evenly into 6 and into 8? And the answer is yes. They can both be divided by 2. Well, 6 goes into 2 3 times. And notice that I marked out the 6. I don't have that anymore, and I circled the 3, which is what I have. Helps me keep track of the numbers that I actually have left over in the problem. And 2 goes into 8 4 times. So now I'm going to multiply across the top, and I have 3 times 7 across the bottom, and I have 11 times 4. So I end up with 21 over 44. And notice that I've already done the simplifying first, so I don't need to do it at the end. I double check and make sure there's no number that goes evenly into both 21 and 44 in case I missed something in my problem. But you can simplify in the problem, in the diagonals, or at the very end as we've done in the problems before this. So let's try another diagonal simplification problem. I have 7 over 10 times 20 over 21. So I'm going to start with the blue here. And I'm going to call it 10 and 20. What goes evenly into both of those? And I know that I can divide them both by 10. Right? In the diagonal, I have to divide by the same number into both numbers. So this becomes 1, and this becomes 2. 1 and 2 are as simple as they come, so I don't have anything else to do there. In the other diagonal, I'm looking at 7 and 21. Well, they both can be divided by 7. And so 7 goes into 7 one time, and 7 goes into 21 3 times. So why do I have those circled numbers? Because remember, this is a multiplication problem, and I'm multiplying across the top 1 times 2 and 1 times 3. So I end up with an answer of 2/3, or 2 over 3. So it's up to you whether you would like to multiply across the top, across the bottom, and then simplify at the end, or if you would like to simplify in the diagonals, in the blue diagonal or the red diagonal like you can see on the screen right now.